Earth is our home, a spinning globe of blue, green, gold, and white, a thing of beauty. But for many of us, think a questions. Many of these concerns that thing which impact us every day of our lives. In global age, so many of us have traveled beyond our borders to lands that are hotter, colder, drier, or wetter than our own. Or perhaps we've even gone halfway around the world and yet experienced weather very similar to our country of origin. And perhaps some of us have asked the question, why is this so? Well, these questions have been answered. They all come under one subject. It's all about the climate.
Climate. Climate is the average weather conditions in a place over a long period of time, 30 years or more. And as you probably already know, there are lots of different climates on Earth. For example, hot regions are normally closest to the equator. The climate is hotter there because the sun's light is most directly overhead at the equator. And the north and south poles are cold because the sun's light and heat are least direct there. Using this information, in the late 1800s and early 1900s, a German climate scientist named Vladimir Köppen divided the world's climates into categories. These categories were based on the temperature, the amount of precipitation, and the times of year when precipitation occurs. The categories were also influenced by a region's latitude. Five main types of climates: tropical, dry, temperate, continental, and polar.
Today, climate scientists split the Earth into approximately five main types of climates. They are tropical, dry, temperate, continental, and polar. Now, let us tackle about characteristics of each climates. First is tropical. In this hot and humid zone, the average temperatures are greater than 64 degrees Fahrenheit or 18 degrees Celsius year-round, and there's more than 59 inches of precipitation each year. Philippines is a country with tropical climate. Second is dry. These climate zones are so dry because the moisture is rapidly evaporated from the air and there is very little precipitation. Dry climates are found throughout the globe, particularly in Western North America, Australia, Southern South America, Central and Southern Africa, and much of Asia. The third one is temperate. In this zone, there are typically warm and humid summers with thunderstorms and mild winters. In temperate regions, there's variations in temperature but not extreme of cold or hot. Typically, the location of these are midway between equator and pole. Example is Japan and USA. The fourth one is continental. These regions have warm to cool summers and very cold winters. In the winter, this zone can experience snowstorms, strong winds, and very cold temperatures, something below negative 22 degrees Fahrenheit or negative 30 degrees Celsius. Regions of the Earth that have continental climates include Siberia and central Russia, and much of North America. The fifth and the last one is polar. In the polar climate zones, it's extremely cold. Even in summer, the temperatures here never go higher than 50 degrees Fahrenheit or 10 degrees Celsius. The two polar regions are the Arctic and the Antarctic.
This is roughly where those climate zones appear on the globe. Distance to the equator is only one part of an area's climate. Things like the movement of the ocean and Earth's tilt and rotation also affect how weather patterns move around the globe. If you classify the United States with a climate zones, it actually looks like this. Climate zones can be useful for gardening and farming. Plants grow best in climate conditions that are found in their native ecosystem. For example, if you want to plant an apple orchard in your backyard, you should first check to see which varieties of apples are a good match for your region's climate.
Weather satellites mostly help with tracking conditions that are happening right now and forecasting weather in the near future. However, they also collect information that help us monitor a region's climate over time. For example, satellites in the GOES-R series, short for Geostationary Operational Environmental Satellite R, can monitor the sea surface temperature in the Gulf Stream, a powerful current in the Atlantic Ocean. Both of these things can influence a region's climate. In addition, the temperature of the land becomes cooler at night, and there are changes in the amount of clouds. The GOES-R series satellites monitor cloudiness and land surface temperature, information that helps scientists to understand how the difference between day and night can affect a region's climate. Satellite in the Joint Polar Satellite System, or the JPSS, can also provide information on differences between day and night. For example, JPSS orbits Earth twice a day in what's called an afternoon orbit. As the satellite orbits from North Pole to South Pole, it captures observation in the afternoon on one side of Earth and observation of the early morning on the other side of the planet. While GPSS orbits, the satellite provides global observations of how many other variables that influence climate, such as atmospheric temperature and water vapor, snow and ice cover, vegetation, sea and land surface temperature, precipitation, and more.